All right, looks like it's working. Here we go. I'm going to keep this lecture light. I want you to have fun today, but at the same time, I have to get something out of it. So bear with me. Here we go. This is my approach to designing an experiment in AP Physics. Okay, so you have a copy of this now in your Google Classroom, a PDF, and there's an assignment that you have to do. It's not hard, I hope anyway. This is my recommended approach. First thing you need to do is you need to develop a clear objective, okay? And I'm going to go through an example of this. Once you have your objective, and in our example, our objective is to prove that a velocity of a car is constant. And we're going to develop a math model. What do I mean by a math model? I want you to find an equation that contains the thing that you're trying to prove and some other variables that you can measure, okay? And I'll give you some examples of things that are hard to measure. Okay, once you have your math model, so you have your equation that has the thing you're looking for, which in this case is going to be velocity, and you should identify two physical characteristics like distance or displacement and time that you personally can measure. And not everything is easy to measure, by the way. Like, for example, if I were to drop this pen and try to measure with some measurement tool the final velocity right before it hit the table, not really easy unless you had some pretty high-tech equipment to measure the velocity of this guy, okay, as it hits the table. So you want to identify two characteristics that you can measure that with equipment that's in a standard lab room, which mostly involves, for now, stopwatches and measure tape measures or a ruler. Okay, those two physical characteristics that you can measure are going to become your variables. One of which you're going to change, that's your independent variable, and one of which is going to then be impacted by that change, that's your dependent variable. Okay, once you know what you need, you develop your material list, and then a procedure. And I don't need a novel, okay? So we need like a short bullet list, okay? So, and then how do you evaluate your data? And we're going to work on trying to develop a graph every time. If we can figure out how to take our data and prove the objective, that's what you want to do, because that's how you're going to become better at, let's say, physics experiments. So let's do a design, and then let's get to the fun stuff for the day, okay? So let me give you an example. And last year, my physics, every single time they walked into a lab, they were given an objective, and the first thing they had to do was develop a math model. And I made them do it all year long. So every time we do a lab in here, whether it's virtual or not, if it's virtual, I'm going to ask you the question, what was the math model? And that's going to be something in addition to whatever the lab is. So a student claims, let's take an example. A student claims to own a constant velocity car. Design an experiment to determine if the car indeed has a constant velocity. All right, so if you go through your notes and say to yourself, well, do I have an equation that involves velocity? Sure, I do. Velocity average, the average velocity of an object is equal to its change in position over change in time. Now, there's lots of other equations out there, but this is a really good one because why? Because I can measure the change. I got two variables that I can measure. I can measure the change in displacement, and I can measure time. And right now, the only real tools that you have in your toolbox is some type of ruler or tape measure and a stopwatch. Okay, so right now, I don't expect you to be giving me any other tools other than a ruler and a stopwatch. So what are your variables? Well, we have change in displacement. So I'm going to measure the distance that it goes in a straight line. And I'm going to use a ruler, right? So that's going to be, let's see. So I'm going to measure change in displacement, and I'm going to measure time. And I'm going to say that it doesn't, in this particular lab, I can pick and choose which one I'm going to change. Maybe I'll change time, and I'll call that my independent. And then I'll say, I'll go for 5 seconds, and then I'll go for 10 seconds, then I'll go for 20 seconds. Or better yet, let's do it differently. I'm going to, let's call this my independent. And so I'll go for 1 meter, then 2 meters, then 3 meters, and then I'm going to find my time. So this is dependent upon what my delta X was, right? Okay. Now, what are my material lists? I need my car, I need my stopwatch, and I need some way, I'll say a meter stick. Okay. All right, so I'm going to have a sketch. So here's my car. Here's the ground. I'm going to call this position 0. I'm going to make a mark at 1 meter on the ground with a piece of tape, maybe I need some tape. All right, and then I'm going to have a spot at 2 meters. And then I'm going to have another one over here at 3 meters. Obviously, that's not to scale, and onward and forward. And then let's put a procedure together. Using a meter stick, place a piece of tape every 1 meter, okay? And then place the car at 0 meters. Start the stopwatch the instant you let go of the car. I have a better way, but never mind. That's easy for us to understand. Record the time that it takes to go a distance of 1 meter, 2 meters, 3 meters, 4 meters, 5 meters. My table of data only goes up to 3, but that's fine. And then this is critical. You will miss points if you don't do this. If you need to repeat, you have to state in your procedure to repeat it 3 times because of error. So you're going to average your data because you're not perfect at measuring that time at 1, 2, and 3 meters. So you need to do it again, and you need to do it a minimum of 3 times. That must be stated to reduce error. Okay. And then here's the thing. If I plot X over time, so what is on top is my y-axis, and what is on bottom is my x-axis, I'm going to get some hopefully constant variable, which is v, and that is going to be my slope, rise over run, okay? So here's some data table what it looks like, all right? So let's recap what we did. I had to decide that I wanted to measure the velocity of a car. I came up with an equation with some variables that relate the velocity of a car to 2 things that I can measure, okay? Using a stopwatch and a meter stick, because that's pretty much all you got in your toolbox right now, all right? Math model is the key. The first thing is try to find a math model. Now here's your assignment, and hopefully it's fun, okay? Don't stress out. No one's going to get hurt or on their, I want you to have a good fun at the cost of someone with a good sport. I want you to watch the Fun with Physics video that I included, where a wonderful student provides an excellent example of projectile motion. Now in that video, which is only 3 minutes long, so it's more about having fun today, I'm going to start talking about impulse and forces. That has nothing to do with what we're doing today. Okay, we're talking about projectile motion, all right? In fact, actually, I noticed that my whiteboard that's in the middle of the yard actually has the some equations. So here's the assignment. This is the challenge for you. What is the math model? Actually, I want to do that. What math model, so give me an equation that you can use to find the initial velocity in the x direction. I'm not going to help you. There is an equation that you can have the initial velocity in the x direction that has 2 other variables in it that you can measure, okay? Remember, you should find an equation that you know has 2 things you can measure, assuming you were in the backyard with the student, okay? Would love to have you over. What are those 2 variables that you would measure? That's number 1. That's your first question. Give me your equation and give me those 2 variables that you can measure, okay? Number 2, this one's harder to see, but there's another equation. What is the math model that you would use to find the initial velocity in the y direction? Okay, so now you got to find an equation in the y direction that has only things that you can measure, okay? So it's a parabolic shape. There's some things that you should know. There's a spot in the parabolic path that is a very important spot. And then it has 2 variables that you would measure, okay? So don't pay attention to my conversations about force and impulse and all that fun jazz, all right? Those are 2 questions. You can submit Just a typed answer, however you want, a picture of your two answers. I don't care. Have fun with it. Enjoy Sydney's demonstration of projectile motion that she did last year for me in COVID's first month or two of time. So that's what I got for you today. Enjoy your weekend. Stay safe. Be nice to your parents.